Hello everyone, June 21st. Alright, deep down in writing. Again, every day is writing. The goal is to finish the paper by the end of the week. And I have a lot more to go. But, I have one more section to go today. I did related work. I did methods. So I'll go through the methods one more time, and then I will definitely finish today also the section for data collection. And there's a little bit more on data collection. I probably have to draw a plot, some other plots, but that's fine. Yeah, we'll see how long it takes to write the data collection. If it's done, let's say we finish data collection, then tomorrow we can do challenges. So I have a section for challenge. Yes, we have a section for challenge, and then we have a section for the... Actually, I'm not sure if that's the best way to organize the paper. But anyway, let's do today. Best time to buy and sell the stock with a transaction fee. Oh, it's the stock purchase stuff. Damn, I forgot how to do this. I've done this I don't know how many times. All right, you're given a price, the price given, an integer fee, a transaction fee. Find the maximum profit you can achieve. As many as you like, but you need to pay the transaction fee for each transaction. No multiple transactions simultaneously. Do you remember how this one is done? I think it's a different one. Right? You buy and then you sell. And you can do it multiple times. I think it's probably DP. Like at each one, you can choose. You have the previous. I think we still do it. I mean, we remember this type of problem is using the state machine, right? We have an empty state and we have a holding state, right? And then from empty state can go to holding state by buy. From holding state go to empty state by sell. And holding state can do nothing. Empty state can do nothing, right? So we're talking about the profit. So we have a starting profit at empty state and holding state. I forgot which one is negative infinity. Which one is 0? I mean, I think the holding state, right? So the holding state, at the holding state, I can choose to either do this or we can sell. An empty state, I can choose to do this or we can buy. And then just, keep going, right? Keep going. So I think the thing should be, we have a holding state, empty state. I think the holding state is a negative infinity because nothing to hold. Empty state, the profit is 0, right? And we say for price in prices, holding state, empty state shall equal to, we want the maximum profit, right? So holding state, I can just do holding state or previous empty state by, so minus P and minus phi. Okay, and then the empty state I can remain empty, or from empty state. Oh, sell, my bad. Holding state can sell, right? So next holding label can sell. So actually it's plus P. Now it's H. The current holding state. No. You're wrong. You're wrong. To arrive at the holding state is from previous. So it's an empty state minus P plus, and then for an empty state, to arrive at empty state is by itself or the previous holding state, sell, and then minus phi. I want to do this until the end. Let's give it a shot. See if this makes any sense. Okay, so I have a holding state, empty state. Holding state is negative infinity empty state. As for P in prices, I say holding empty equals to maximum holding an empty state. I call it empty state minus P minus phi. And this empty state, holding state plus P minus phi. And then we return empty state. All right, let's see. Is this correct? 1, 3, 2, 8, 4, 9. Phi is 2. Answer shall be 8. 1, 3, 7, 5, 10, 3. Phi is 3. This is 6. Prices, phi. Max profit. Nope. Ugh. That is not correct. Alright, I'm not sure. I'm not sure if it's even right. I'm not sure if this one is right. That's do we get these two wrong? I'm not sure. 0, 0 I think is wrong. No, I believe this is the transaction. All right, let's get the transaction to be 0. Let's see if it's correct. Buy and sell. Shoot, as I've done this so many times. Buy, sell. I think this is the one. Unlimited number of times. Is this the one? Yes, that is correct. So I did remember, okay? I did remember. See, this one is correct. So I did remember the thing, but with the transaction fee, apparently it's not the same. I don't know. Pay the transaction fee for each transaction. And I'm short. Buy 1, sell 8. Right? Buy 1, sell 8. by 4, cell 9. So should be 7 plus 5. Right, 7 plus 5, 12. 12 minus 4, yeah. Let's see if it becomes 0. I got 13. 13 is not right. Wait, hold on. It might be, so it's 2, 6, 8. Yes. Yes, it is correct. But with the fee, that is not correct. Because with the fee, I think what do I have? I got 4. How did you get 4? I don't know. It's very interesting. It is very interesting. I think this probably means this method does not work. Now we can just take a look. Holding. Maybe holding should be negative math infinity. Because it's never get out of -3. Because it's basically, it's this. What if holding is just minus phi? Nah. Ain't right. What do you think? I mean, this just means that we buy, right? We buy at a 1. If we buy at a 1, wait, hold a second. Hold a second. Pay the transaction fee. No. This is considered one transaction. Buy is one transaction. I think I know the trick. There's only one transaction, so I need to divide it by 2. Holy crap. Divided by 2. Well, what we can do is you buy, and then we only do when you sell. There we go. There we go. There we go. Now it makes sense. Problem shall be more clear that the transaction fee is only paid when you sell the stock, which does not make sense. Like, it's a transaction. You buy as a transaction, you sell as a transaction. But doesn't matter. We figure it out through trial and error. So, state machine. Last time is 2021. What I was 2021. I know where I was. Still in Florida. Yeah, that's it. All right, let's see. I actually never go through the dynamic programming part. I just, stay machine for doing this. On day I, the profit we can make today is determined by today's operation plus the maximum profit we have made before. The question is, how do we get the maximum profit that can be obtained from the previous I days? Buy the stock, sell the stock, do nothing. Yes, the profit depends on our operations and the maximum profit obtained from the I-1 days. Length n and DPI records the maximum profit we can obtain from the ith day. Okay. Buy, sell, and do nothing. So if we buy the stock, is this plus, you buy it, yes. You sell the stock and you do nothing. On a day I, if we want to sell the stock, the prerequisite is that we must hold the stock. Two different status on day I. Currently holding the stock, not currently holding the stock. Did not distinguish between, that's correct. Program array should also have two states. Maximum profit when free of stock. That is the holding, that is empty state. And maximum profit when holding the stock, that's the holding state. So we need two arrays, free and hold. Therefore, we buy the stock on day I, our status from free to hold. That is the holding state. So we can either hold or the empty state, the free state they call it, minus. Right? So we can also say if we sell the stock, so we go from the holding state, which is this, plus price minus fee, go feed into the empty state. We can also choose to do nothing. Therefore, free equals this, hold equals to this. Wow. Yeah, this author is good. Yeah, the last day we return free. Yeah, we're only using I-1, so you don't have to hold the entire thing. So we can just do this. Yep. Oof, very good. But state machine, and this state machine helps with this. But I still want to know how the dynamic programming kind of mindset is in this. So, all right. Done. All right, back to this ridiculous thing that has been bugging us since I don't know when, but we said we're gonna do hints, so let's take out a hint. Okay, what the problem is, we already find the nodes that will be involved. We use these to find the nodes that needs to be involved. Now our question is which ones to eliminate, right? Which ones to slash, and we hit a bottleneck, and we say the final answer is the price times frequency, where frequency is the number of times node I was visited. The price That is correct. To find frequency, we'll use DFS and BFS or BFS for each trip to update every node on the path. We've done that. We've done that. We have the required nodes. I want to know the last part. Dynamic program on a tree. Okay, this is the key. Let dpv, then this, denote the minimum total price, with the node v's price being halved or not. Huh. dpv. On the tree. What did you do? I did not do it on the tree. What does that mean? We have the required nodes, so to compute is very easy. And to find the price, where we will use dp on the tree. dpv denote the minimum total price, with the node v's price halved. Wait, I don't quite understand what it's trying to get at. I mean, we have this situation, right? We have 1, 2, 0, and 3. And we identify these are the ones. No, which are the ones? All of them. All of them are included. So we say we'll dp it. Okay. Do you mean we just pick any one as a root? Okay, so I pick 0 as a root. So we want to find out when 0 is slashed, what's the price? And 0 is not slashed, what's the price? So then I push it down to this, right? Then I want to know when 1 is slashed, what's the price? When 1 is not slashed, what's the price? But to go through, everyone has 2 options. Everyone has 2 options, but hold a second. Hold a second. If we do dp node and we say slashed, if we put these 2 as a state, what's going to happen? Or we can say this is the price of the subtree. Okay, so we want to find a subtree of this. Then we push it down. And then we push it down. Okay, so at 0, all right? Yeah, let's give it a shot. So what's going to happen? At 0, we will do, because I don't know, it can be 2, right? So I can say we'll do dp 0 true slashed. Okay, true slashed. Then we go to dp1. This has to be false. Okay, there's no, and then dp1 will pass, right, to dp2. Then dp2 we can say dp2 we can false, or dp2 we can true, because this is this, right? And then this path, same, dp3 false and dp3 true. Done. On the other hand, if we go dp0 false, then we have dp1 true and dp1 false. Oh, and this problem is already solved. Holy crap. How did you not do this? Yes, this is the result. This is a freaking result. Huh. Yeah. So instead of backtracking, instead of doing dp0 and then you exponentially grow the total states, you just by separating the states, and the problem is resolved magically by itself. I don't believe this. This is ridiculous. I did not figure it out. Okay. So we do trips, require nodes, boom, done. Now we're gonna dp this. Okay, memo is going to be this. Okay, and now we're gonna say def dp node and slashed. That's a Boolean value. Return integer. Okay. Say if node slashed is in memo, return memo node slashed. Done. Else, if it's not, then we can say, right, if slashed, right, if I am slashed, then my children cannot be slashed. Then I say for child in graph node dp child, if I am slashed, so not slashed, right? So not slashed. And this shall give me the minimum on my child. So I need to have the rest is equal to 0, all right? So rest plus equal to my child, because it's all subtree, right? So the minimum of this, minimum of this, minimum of this, and then all of those. And we shall return, because I am slashed, right? So we return result plus required nodes node, right? The count could be 0 times price node divided by 2, because I'm slashed. Otherwise, I am not slashed. Again, rest equal to 0. We might be able to do this one outside. Okay. Otherwise, we say for child in graph node. Now rest can plus equal to the minimum of dp child slashed or dp child not slashed, because I am not slashed, right? I am not slashed. If I'm not, actually I can make this more explicit. If slash is true, then this has to be false. If slash is false, then I can slash, child can slash, or child can choose not to slash. Doesn't really matter. And I want a minimum of those. And once it's done, I'll return res plus required nodes node times price node. I am not slash, so I don't divide by 2. So we do this, and then we just go, doesn't really matter. We go dp0, right? We go dp0. So we'll return the minimum of dp0. I can call it slashed, or no, it's not slash, true, or dp0 if false. Does this work? Maximum recursion depth exceeded. That is very interesting. Wait, hold a second. Are these correct? No, these are not correct either. Oh, because you never save it in the node, in the memo. If these are not in memo, I'll do all of these. Set memo node slash to equal to res plus if not slashed, and then res plus equal to this, else res plus equal to this. And then we set this to, I don't need to do res. It's just a memo. Memo, right? And we'll return memo. Almost, I guess. Answer is 23. I got 2. Dude, you got 2. I don't know. Why did I get 2? All right, again, required nodes. Yeah, looks all right. 1 3 times, 3 2 times. Yeah, that's correct. Let's say memo. Huh. What? I don't understand. Why memo is empty? I don't know, man. The hell? What? What the hell is this? Oh, I have value. Oh, of course, because you have to do this one first. All right, my bad. So I have to say, let's say res equal to this. Then let's print memo. Don't print it here. All right, and then we'll return res. Okay, now we can see this. 0 true is 29. That's not right. 0 false is 2. 0 false is 2. How did that come to pass? I don't have any clue. I don't know. Doesn't make any sense. 0 false. How can it be 0 is false? I don't slash here. I mean, let's set slash here. 0 is true. Let's slash here. So 1, 0 is 1, so we have 1. And 1 cannot slash, right? 0 true, and then 1 has to be false. And when 1 is false, oh, I think I go backwards. Dude, you cannot go backwards. You need a parent. I need a parent. Node slashed parent for child if child is not equal to parent. If child is not equal to parent. Blah blah blah, and then I need a parent is -1. Parent is -1. I forgot a parent is node. Parent is node. It's a tree, so parent is sufficient. Now we are talking. Now we are talking. Now we are talking. Dude, now we are talking. Let's return directly. I have confidence, man. This time, there is confidence. Oh, I think we might get it. Oh, I think we get it. I think we get it, man. I think we get it. I think we can submit it 19, 2 days. Oh, got it. What do you think? Yeah, I mean, we got everything else. All right, we got everything else. Yeah, we got everything until the last step. We have figured out the total number of nodes involved in the final pass. Thus, the only issue is how is which nodes to slash in half and which not. I was thinking about greedy, but apparently it didn't work. I also thought about backtracking, which worked, but had complexity of 2 to the n. So, to the n. What I didn't realize is that we can move the slash or not slash part into the state. Thus, the state becomes node and whether it is slashed. This way, we can, and in addition, we also traverse the entire tree. Well, we traverse the entire tree to find the minimum price of trade to find DP node slashed as the min price of the nodes in the subtree rooted at node. Yeah, this way we can reuse. Yeah, this way we can reuse. We can reuse the computation did performed previously. Oh yes, for sure, definitely, love to. Done. So this is a trick that I have seen used at least in two problems. Separating an internal state, the internal state that you will probably have to deal with by backtracking. You separate it out into an external state, right, on the outside. And when you do that, you can reuse the stuff you computed previously. I don't know, this feels very interesting. How? I never thought about it. This is an important trick. I think we learned two important tricks in the past few weeks. One is sorted list and iRange. That is a trick. That is a trick. If you know your range, that's a trick to reduce a search space. Not sure if I can still remember that, but that is a trick to reduce search space. And then this, when you have a state, you will pull the state from inside. Or we can say maybe every time we have stuff like this, we can start thinking about, like, we have something you take or not take, right? When you have this, you can elevate that state to the outside. But why backpacking, knapsack problem cannot be done this way? I thought knapsack, isn't that similar? Yeah, knapsack is you take or you don't take. I think knapsack was already done because you have the remaining. If you take, you have something. You don't take, you have something. Here is the same, right? You take and you don't take. But the thing is, one of them, it reduces. I mean, the total number of states is just number of nodes multiplied by slash. Anyway, I think I want to revisit this tomorrow again. Now we solved it, but I want to revisit it. But hold on, this is ON. Right? ON for this. And this is ON times 2. So it's still ON. I think this is ON. It's a very complex ON though, but I think ON is ON, man. ON is ON. We'll see if it's ON tomorrow. But hold a second. Then why knapsack is n times w. Yes, it is n times w. You have w is a restricted positive integer. Yeah, n is total. Yes, that's correct. Yes, this is what I had in mind. All right, maybe. This feels like a knapsack, right? Because you can do this, you can either do it or not do it. But anyway, that will be it for today. Gotta train. Alright, see you guys tomorrow. Adios.